Okay, we're live.
Thanks, Ben. I'd like to welcome everybody to our July RPAG meeting. It's about a minute before we're going to get started. People are still joining us, but I just wanted to say hello and let you know you're in the right space. And RPAG members, as you join, we'd love to have you go ahead and introduce yourselves in the chat. Welcome, everybody. I see some folks are still joining us, and I just wanted to let you know that you're in the right meeting. This is a July meeting of PSE's Resource Planning Advisory Group. Welcome to all our RPAG members who are joining and all our attendees who are joining us as well. It's great to have you all here. I'm going to give it another 15 or 20 seconds, and then we'll get started. All right, we're at 1:01. I'm going to go ahead and get us going so that we can end on time. Welcome, everybody, to the July meeting of Puget Sound Energy's Resource Planning Advisory Group, otherwise known as the RPAG. I'm Hillary Wilkinson, and I'm with Mal Foster and Alonji, and I will be facilitating today's meeting. It's really great to be here. Thank you for everybody for taking the time to join us. We've got some important things to cover today. I'd like to invite all our RPAG members, if you're comfortable, so please go ahead and come on camera so people know who you are. Also to please introduce yourselves in the chat. Your name, your entity, maybe your position would be great. And please remember to use the everyone option so that everyone can actually see what you're saying, both participants and attendees. So I am going to walk through a few introductory slides just to make sure everybody in the meeting today is oriented and can engage in the meeting to the maximum extent possible. So Jack, if you could please advance the slide. You're going to hear me call out the names Jack and Ben. Those are two of my colleagues who are helping me behind the scenes. And so huge thanks to both of them for helping things go smoothly today. So we are obviously in a Zoom meeting. I'm sure everybody has been in a Zoom meeting at this point post-pandemic. And all RPAG members are very welcome, and PSE staff are welcome to use the chat feature, which is down at the bottom. You can also use the react feature to either raise a hand or give a little emoji. All participants can use the emojis, and also the show captions sign is available for real-time closed captioning. Yeah, next slide, please. I have a few requests. I'm not going to cover all of these, but as facilitator, my job is to really make sure that everyone in this meeting, all RPAG members, can engage kind of constructively and effectively and have equal opportunity to share thoughts and comments and questions. And so I ask that you engage constructively and courteously towards all participants. For all speakers, as well as RPAG members, when you're asking questions, please spell out acronyms, explain technical questions. Not everybody is as savvy on the topics that are getting covered as those of you who are deep in it. So please remember to do that. And we ask also, number 5, to focus on the webinar topic, which we'll talk about in just a second. A few of these other numbers just have to do with feedback. We very much welcome feedback both during the meeting and after the meeting. There's going to be a feedback form that Ben will share in the chat after the meeting, and we'll have public comments at the end. So I think that's enough on facilitator requests. Let's go to the next slide, please. We always do a safety moment, and this month, preparing for peak wildfire season is the topic. 4 quick things. First, we encourage you to create a household emergency plan and build an emergency kit. Second, make sure your PSE account contact information is up to date. So if there's an emergency alert, you can get it. If you use a home medical device that relies on electricity, you can apply for a life support status on your account. And finally, you can get a free wildlife ready plan from the Department of Natural Resources. Next slide, please. We have several speakers today, and I'll be kind of walking through who they are as I go through the agenda, but here they are. You can take a quick glance. You'll be meeting these folks and hearing from them in just a little bit. Next slide, please. So this is our agenda. We're going to start with about a 5-minute kind of recap by Jen Colson about where PSE has been and where they're heading. And Jen is the Director of Resource Planning Analytics at PSE. You've all met her before, and it's going to be a fairly brief presentation, and we'll have a little more time in August to go into some of the content of what she's talking about, so just a heads up on that. We are then going to go into a presentation by Nisi Weatherby and Dan Oss on the electrification potential assessment results. That's going to be about 55 minutes, lots of time for Q&A, and we also have a couple questions for our RPAG members. Then we're going to move into the draft scenario demand forecast results. Lauren Melander from PSE will be presenting that information. Also time for Q&A and also a couple questions for RPAG members. And then lastly, we'll do next steps and we'll have an opportunity for public comment. So that's today's agenda. So a few reminders before I hand it off to Jen, our first presenter. The first reminder is that sorry, pause. Can you go to the next slide, please, Jack? Yeah, I forgot to share this. We really invite questions, reflections, and comments from our RPAG members. We really welcome that, and during the public comment period as well. We're especially interested in knowing if anything is missing or unclear, so please flag that for us. If there's something that needs a deeper dive, let us know that as well. And yeah, this just helps us sort of highlight areas that we need to focus a little bit more on. So I see a hand raised. Yeah, Lauren, go ahead.
Yeah, thanks. I just wanted to ask if folks could put their affiliation in their name. I just attend a lot of meetings and I can't always remember who everybody is with. So I would appreciate it if folks would identify their org. Thank you.
Thank you, Lauren. That's a really, really good reminder. So if folks could please do that, just there should be 3 little dots next to your name. If you could please hover over it and update your name. You have to hit rename. You have your name and then put your affiliation there. I totally agree with Lauren. It helps a lot. And I know a lot of RPAG members are still getting to know each other. All right, so before we move on, just a couple really quick reminders. One, again, is to use the chat to post questions. Please try to stay on topic of the topic at hand. And remember that there will be a feedback form at the end of the session that Ben will post, so you'll have an opportunity. We will do our very best to get to all of the questions. 2 hours goes quickly, so the feedback form will be where PSE can address any unanswered questions in the session today. So with that, I'm going to go ahead and pivot us to the first topic at hand, which is Jen Colson, the Director of Resource Planning Analytics at PSE. She's going to spend about 5 minutes just talking about kind of where PSE has been and where PSE is going in regards to this development of the ISP. So Jen?
Yeah, thanks, Hillary. We can go to the next slide. So I'm going to dive into a bit of the feedback we've received in the May and June RPAG meetings, but before we do that, we thought it'd be helpful and a good point in time to kind of revisit where we've been on this long journey of developing our first integrated system plan and where we're going to go with it. So we are actually approaching our 2-year mark on development of this integrated system plan. It's been a long journey with all of you, and we wanted to highlight the involvement and the how we've consulted with you along the way since we've kicked off this process back in September of 2024. And just thank everyone for their involvement and their time and the development of the scenarios, the methodologies, and the sensitivities. And as we look to box number 7 on the screen, we're starting to get into the results. So it's really showing all of the hard work and the answers that we've been all eager to see. So on the next slide, before I go into recapping the feedback and the themes that we've received on the reference case, I wanted to spend a couple of minutes talking about the challenges and a lot of the reason for the feedback that we've received and just reorient us on what it was. So in May, we talked about the electric supply portfolio and the modeling challenges we experienced, specifically in the electric supply space. We use a model, optimization model called Aurora. And this model is essentially looking to solve for 3 big components, and they all have to be true within any hour of the study period. So effective peak capacity, the Clean Energy Transformation Act, renewable and non-emitting resources, and the energy demand. And based on how we set that up, we found that in 2045, with the removal of the gas peaking facilities from the portfolio on the electric supply side, the model was actually unable to produce a feasible solution. And this was because we limited the available technologies to the ones that are available today in the market. So to try and find a solution for this, we worked on 2 possible outcomes. We first started with reference A on the left-hand side. And this was really focused on how can we use the resources that are available right now to help solve this problem. When we went into the model to figure out what about the resources that are available today is not working, we found that wind and solar were actually maxing out the builds across the region. And we have transmission limits on this bullet here, and I just wanted to point out that we do assume Bonneville Power Administration does do transmission upgrades in the reference case. So we assume that they do the evolving grid projects and about half of the evolving grid 2.0, and we do have the details of that in the deck. So this isn't today transmission, right? This includes improvements. So we find that that's maxed out. And so the next option was the 4-hour energy storage. So we looked into forcing that as a solution. In doing so, it wouldn't necessarily solve by itself. There was a lot of hand-holding involved, and the outcome was really expensive and required over 50 gigawatts of batteries by 2050. Because the scenarios that we're developing as part of this ISP only increase the electric demand, we considered reference A not a feasible outcome because that would not solve for those increased electric demands. So we allowed emerging technology as reference B. And when we say emerging technology, we've defined the following resources. All of these resources were offered into reference B as an option, and the portfolio optimized based on least cost. So we provided it small modular reactors, advanced geothermal, mid and long duration storage, renewable peakers, and offshore wind. So those were the options that the model had to choose from. Based on having that availability, it was able to produce a solution. And so we had reference case B. This reference case is not our answer. It is the starting point. We're using this to scale up for the scenarios as we see increase in electric demand and do further sensitivity analysis. Let's go on to the next slide. So this brings us to the feedback and the themes that we received based on that information we shared. So this slide summarizes the high-level themes of questions and concerns that had been raised in the meeting and in the feedback report. We received a couple of comments in the feedback report regarding the desire to see an alternative reference case, so something between reference case A and B. We do feel that we can address this with multiple sensitivities. And after further review, we found that the desire for this middle ground reference case is really based on the definition of emerging technologies. So there are differing opinions regarding what we're calling emerging technologies and the WAC definition of commercially available, where it talks about reasonably anticipated to be available within the integrated system plans study period. So because there's a difference in opinion there, we do think that incorporating the emerging tech, all of it into the reference case does help address that. And then we're also going to test some additional emerging tech sensitivities to really help ensure that we've covered all the bases that were requested. We also had a comment about our fossil resource assumptions, really just wanting to make sure that we've incorporated all the costs associated with those flex fuel peakers that we have identified in the portfolio. And we do include the fuel, acquisition, transport, and storage of that flex fuel as part of that peaker cost. So we do feel like we have all those costs associated with that. Part of the sensitivities and the comments was about limiting the amount of that flex fuel availability. And so we're looking into that as well. There, in the meeting in June, we talked about the electric transmission and delivery system. And there was comments about the non-wires alternatives and the success rates that we had identified for the reference case. And so the team is going to test out those different levels of the 20, 30, and 40% success rates. And this is specific to the success rate of a non-wire alternative to avoid system investment. And the last one I haven't talked about quite yet is the emerging tech timing and costs. So again, we're going to address this from sensitivities. Specifically, this was about geothermal, so reducing the cost of geothermal. So we're able to incorporate that. And then also looking at long duration energy storage specifically. So we'll be incorporating that into the sensitivities as well. I think next slide. So where we're going, so as I mentioned, it's been a 2-year run as of now, and we have about 5 to 6 stakeholder meetings remaining through the end of this first integrated system plan. We do plan to revise our ISP work plan in August with those remaining meetings, and we're going to have a draft ISP and executive summary at the end of the year, so that's exciting. Between now and then, we'll be going through a lot of information where we'll have the scenario and sensitivity results, decision making, and preferred portfolio, the distribution of benefits, the C to targets and goals, and then developing and publishing the draft ISP. I think that's the end of my slides. So any questions?
Great. Thank you, Jen. And before we take a question, I just wanted to note really quickly that we intentionally had Jen's section pretty short, even though there's probably a lot of questions. We want to make sure we have time for the 2 major topics today. A lot of what Jen covered was covered in previous meetings. And if you look at the May and June feedback reports and summaries, there's a lot more detail about it too. And we will also pivot back to some of those topics in our August meeting and have a lot more time. But for now, I'll take one question and then we'll move on. So Katie, go ahead.
Thank you. Yes, so PSE and Renewable Northwest met last week to make sure there was, I guess, common understanding of the feedback that Renewable Northwest has provided up to this point. It felt like we left the meeting on the same page, and I just want to make sure I understand PSE's action plan going forward. So last week it sounded like your modeling team was committed to trying to run a new reference case that was, respecting the WAC definition of commercially available, leaving out the flex fuel peakers. But now it sounds like that will only be folded in as a sensitivity, and PSE's committed to reference case B without testing this middle ground approach. Is that what I'm hearing?
Hi, Katie. Yeah, so I'm sorry for the misunderstanding. Yes, we will be testing it as a sensitivity, and I think what we're trying to help understand is that the reference case is just the starting point. So if there are findings in the sensitivity that lend itself to be helpful and informative that we want to incorporate into the preferred portfolio, we can do that. So we don't see it as limiting to not have it as a reference case. The challenge with the reference case, again, is that scalability, and we really need to be able to move forward with our modeling for the scenarios and that increase in electric demand that we're actually going to talk about in a little bit.
Thank
Okay.
you, Jen.
Yeah, all right. Okay.
Thanks for that question, Katie. And, again, we'll circle back to some of these topics again in August. And please look at the May and June feedback reports. There's a lot of detail in there. But in the interest of time, we're going to move on to our first kind of major topic today, which is the results of the electrification potential assessment. And I am going to turn it over actually to David Landers, who's the Director of Planning at PSE, who is going to introduce this topic as well as the two speakers for the topic. So David, I'm going to hand the reins to you.
Thank you, Hillary. Good afternoon, everyone. Yes, I'd like to say just a few words to set the context for today's discussion around our non-pipeline alternatives analysis that our presenters will be sharing with you, and especially our electrification potential assessment. If we want to go ahead and go to the next slide, please. I just want to point out we view the purpose of today's presentation as informing the RPAG of the results of this analysis. This is our first effort toward developing a structured top-down methodology for evaluating electrification potential for our known needed investments in the gas delivery system. For the RPAG, there are a couple of requests from you today. If we move to the next slide, we would like to hear initial reactions on the results of this first analysis, as well as to get feedback on methodology to inform future analysis in the next planning cycle. If we go to the next slide, the analysis presented today has been conducted to fulfill specific requirements for development of the ISP, and you see some of them listed on the slide here. Per WAC 48096-040, and I'm quoting from that, the integrated system plan must include an assessment of cost-effective electrification that encompasses the potential for geographically targeted electrification. So PSE has acquired the services of E3, Energy Environmental Economics. They're a leader in conducting system-wide analysis, and so we have brought them on board to conduct our first electrification potential evaluation, which includes geographically targeted electrification. So what you will see today is their analysis for major categories of projects that are currently known and being planned. And they also have taken a look at our pipeline replacement plan in this analysis. This evaluation is going to inform our analysis of options that, and I'm quoting from the WAC rules here as well, take into account opportunities to make more effective use of existing delivery facilities through non-pipeline alternatives, and assess non-pipeline alternatives, including geographically targeted electrification and gas demand response, as an alternative to replacing aging gas infrastructure or expanded gas capacity. And then moving down to the third box here on delivery system assessment, WAC 48096-0403B. Regarding non-pipeline alternatives, there is a requirement that the ISP provide location of planned pipeline replacements and repairs in the assessment of geographically targeted electrification. So I just want to let you know in today's presentation, you will not see pipe segments on a map, but we will discuss the most likely feasible locations for targeted electrification to address pipeline replacement needs. And also, as we discussed non-pipeline alternatives for our known reliability projects, we will not be referring to those projects by name. We'll be referring to them by a number today because these projects are still in development and subject to modification between now and finalization of the ISP. We go to the next slide. So just some terminology up on this slide. So we have followed these definitions in conducting the electrification potential assessment to evaluate geographically targeted electrification and non-pipeline alternatives. I just want to say that this is a nascent area of energy delivery system planning. Terminology currently tends to vary across the industry. So if we make any, we have followed these definitions in conducting this analysis, but if we make any statements today that are unclear in how they align with these requirements, or you need clarification, please ask so that we can clarify specifically what we're talking about. So just wanted to share that to set up the context for what is being presented today. At this point in time, I'd like to hand it over to Dan Oss with E3, and he can introduce some of his colleagues that are online with him today as well that have worked on this analysis. And once Dan and team have taken us through this presentation, Nisi Weatherby, our manager of gas system planning, will come up at the end to talk about our next steps and how we'll be applying this analysis in our ISP development.
David, thank you. Before Nisi pops on, I just wanted to say, Sophie, I see your hand is up. I'm going to ask that folks hold their questions until we're more through the presentation, if you don't mind, unless you have a clarifying question about something David just introduced.
I had a clarifying question about what David was just saying about how it fits in with the WAC requirements. I can wait though if you want, Hillary.
Yeah, if you don't mind, Sophie, I'd love to make sure we have enough time for both Nisi and Dan. So we will circle back. Thank you for your patience. Okay, Nisi, handing it over to you.
Actually, Dan.
Straight to Dan.
Sorry, straight to Dan. Dan, it's yours.
Great, thanks all. We could advance to the next slide. I can introduce myself and my team. My name is Dan Oss. I'm a partner at E3. We're a national consulting firm based in San Francisco, but have done lots of work in the Pacific Northwest. I'm joined today on the call by my colleagues, Sean Smiley and Vivan Malkani, who helped lead this analysis. And we also had a great team from E3 listed there, as well as really excellent collaboration with PSE throughout. If we could advance to the next slide. So the goal of this project is to support PSE's integrated system plan via a service territory-wide non-pipeline alternative analysis, specifically focused on geographically targeted electrification. So we're doing both a study as well as helping develop a process through which ongoing integrated planning of this sort can be developed. Next slide, please. So I'll briefly introduce the study approach and then we'll get right into results. So if you can advance one more slide. As David mentioned, this analysis looks at known projects, which you can consider in a couple of different categories. The two major categories are what we're calling specific projects, and these are 7 large projects, typically transmission, but sometimes distribution, that PSE plans to implement to support reliable service on their system. It's one big category. The second big category are DuPont replacement projects. This is approximately 170 miles of 1970s vintage pipe that is slated for replacement. I think it's important to clarify this is not referring to the community of DuPont in Pierce County, but rather the DuPont Corporation that manufactured a vintage of plastic pipe that is of concern. And then we looked at a handful of other much smaller programs that PSE is looking at that I'm not going to go into any great detail, but did for completeness. For that planned set of gas projects, we applied a technical, economic, and adoption feasible funneling or screening approach. The technical potential step is really looking at the hydraulic feasibility of avoiding gas investments through customer-facing NPA measures. And I'll describe what that means in a few slides. We also include an economic potential, which is a cost-effectiveness screening comparing avoided project costs to incurred NPA costs. And then finally, we have an adoption feasible potential, which is really looking at, for the projects that clear the technical and economic screens, what share of those or how likely would those projects be to be achievable from an adoption perspective. And I note here we took an approach that gives something of an upper bound for what might be possible there. And in practice, there's going to be a realization rate of the projects that clear that step. That is kind of difficult to say what it would be at the outset, but we can talk more about that in the coming slides. Next slide, please. So we looked at each of these projects through three primary cost effectiveness perspectives that are really designed to answer different questions. On the left, we have a joint utility cost effectiveness perspective, which answers the question, would NPA implementation increase the total combined gas and electric revenue requirement for the customers being served by these projects? We also have a modified total resource cost perspective, which includes emissions. So this answers, do the total benefits, including avoided emissions, exceed the NPA project costs? And then we have a ratepayer cost effectiveness perspective, which asks the questions, how would electric and gas ratepayers respectively be affected by implementing this NPA? The presentation today is really going to primarily focus on the first and second perspectives, but the third one is also important for thinking about how these programs might be funded in the future. Next slide. So I'm going to start by talking about the DuPont Pipeline Replacement Program, which is an opportunity for potential target electrification projects. Next slide, please. So just to orient you on PSE's gas system, today they have approximately 13,000 miles of distribution main on their system. Of that inventory, 165 miles of pipe are being targeted for replacement because they have characteristics that make them at risk of failure. This is an ongoing program that PSE has had since 2013. 165 miles are remaining. And to date, really all the most high-risk pipelines have been remediated, but there is still an ongoing effort to take out the remainder. So this population of 165 miles really represents one of the larger chunks of planned projects that PSE are looking at today. Next slide. Our first screen from that total inventory of DuPont pipes is our hydraulic feasibility screen. And what we mean by hydraulic feasibility is whether a given gas asset can be removed from service without stranding or causing reliability issues for other customers downstream. So we divided this into a few different buckets. The first are terminal customers or terminal branches of the system. These are the endpoints of the system where there are no downstream customers relative to the DuPont replacement project. So if you remove that pipe from service to a first order of approximation, you shouldn't affect other customers on the system in an adverse way. On the opposite end of the spectrum, we have in red infeasible customers, which based on our GIS analysis, decommissioning them would strand customers downstream. So the contrast here is the terminal you might think of as the very end of a branch, where you can cut off the branch without affecting the rest, whereas infeasible would be closer to the trunk, where if you remove a piece of the branch further upstream, you're going to have to cut off the whole branch and strand customers downstream. In the middle, we have this category called potential system impact. And these are parts of the system, for example, ones that are networked or gridded, where there might be multiple paths for gas to reach a customer. So if you remove a pipe from a gridded system, there are potential alternative pathways. But that really requires hydraulic analysis to determine whether you can, in fact, remove that asset and maintain reliable service. Next slide, please. So for the purpose of the rest of the analysis, we look at both the terminal and potential system impact, since those are the ones that are at least plausibly technically achievable. And then we look at a cost effectiveness screen using the utility cost test as our primary screen. And that is really looking at, do the costs of incentivizing electrification and electric system costs, how do those relate to avoided pipeline replacement costs? And when we look at that, we see that approximately 8 miles of terminal branches are UCT cost effective and 54 miles of potential system impacts. And that's compared to 24 miles that we thought might be technically feasible and 80 miles that are technically feasible for potential system impacts. One element of PSE system that's important to understand for cost effectiveness is that they have fairly different replacement costs depending on location, and that's shown in that table in the bottom right. So in Seattle, the cost to replace a gas main is approximately $6 million per mile, whereas outside of Seattle, the average is closer to $2.3 million per mile. And this becomes important as you think about the value available for a given target electrification project. And we'll show you how that impacts the dispersion of these projects in a few slides. Next slide, please. Our final screen is a customer adoption screen, which looks at whether these projects are potentially feasible from an adoption perspective. And I think an important feature of these projects to understand is that if you want to avoid a DuPont replacement, you need to electrify every customer that's being served by that asset today. We at E3 often call these zero gas projects. What that means is you have to have 100% customer agreement in order for the project to go forward. What we observed from experience in other utilities, such as PG&E, as well as materials that were documented by RMI and National Grid in a 2024 report looking at the empirical experience of non-pipeline alternative programs, is that approximately 5 customers is the maximum that have been able to uniformly say yes to a project. And so this last screen really looks at what share of those cost-effective projects have less than or equal to 5 customers being served by them. And that leaves us with 1.7 miles of projects in highly impacted communities, 4.3 miles in other communities within the terminal population, as well as an additional 26 miles in the potential system impact category. And so this is, again, something of an upper bound, or at least a higher bound of what might be possible from an adoption feasible perspective, because you're unlikely to get every site with less than or equal to 5 customers to say yes. You'll probably have a realization rate that's a fraction of those mileages shown there. Next slide, please. And this analysis is all based off of a granular spatial analysis and allows for seeing where potential opportunities might exist throughout the system. So as I mentioned, Seattle has relatively high costs in terms of replacing gas pipelines. And as you can see on this map in the darker shaded colors, there are more utility savings to be had by incentivizing electrification to avoid DuPont pipe in Seattle than in other parts of the system. In the joint service territory, we found that Pierce County has a relatively high share of sites that meet those hydraulic feasibility, adoption threshold, and cost effectiveness screens, and might be another promising area to look. Although I note there is one caveat to this analysis that we assume that for any individual project, because it's around that less than or equal to 5 customer level, that there will be limited electric distribution system impacts. However, if you were to aggregate multiple projects together, particularly in a capacity constrained area like Pierce County, you could have more material impacts, and that would need to be re-examined. Next slide, please.
Dan, I'm going to pop in real quick and share a question that came in the chat, and also see if there's other kind of clarifying questions, because there was a lot of information that just got shared, and I suspect there's some questions out there. But the question in the chat, either for you or others to answer in the call, is from Byron. What does first order approximation mean in the context of no downstream customers?
The first order of approximation I was referring to there is saying that from a hydraulic perspective, there being a terminal branch is a very strong indication it would be hydraulically feasible, but you would still want to analyze it in a hydraulic model prior to making that determination, prior to moving forward with the project.
Great, thank you, Dan. And Byron, I hope that answered your question. If not, please pop your hand up and we can address it further. And Sophie, thank you for your patience. I know you had a question earlier related to the WAC, I believe. So go ahead, Sophie.
Yeah, maybe I'll ask a question first about what Dan just shared, since it's top of mind. So just to make sure I'm understanding correctly, when you went from the hydraulically feasible to the cost effective, you're taking all of the possible potential system impact category and looking at it, not necessarily assuming that all of those will be available, but looking at them nonetheless. Is that correct? Like going back to slide 26?
Yeah, that's right. That's
Okay.
right.
And I had another question about why not include places with more than 5 customers? Like, it seems like the cost to reach out to a place that had 6, 7, however many customers could be fairly low. And even if the success rate is, not expected to be high in the segments with higher customer count, why not reach out to them anyways?
I think that's a bit of a program design question. What I'll say is from an analytical perspective, our intention was to start from the widest possible aperture of what's the total population of DuPont, and then to show increasing levels of a funnel. And so we're not trying to say that you couldn't do more than 5 customers, but that's a reasonable heuristic based off of existing industry experience. And so what PSE chooses to do with the information, if there are sites that have more than 5 customers, I guess it's an implementation question I'd leave to PSE.
Thank you for that response, Dan, and then for that question, Sophie. Megan, go ahead.
Yeah, thanks. So I think the analysis you're doing of DuPont is great and would love to see similar analysis on of other sites. My question kind of goes back to the process side of things. There was a technical and economic and feasible potential, but it seemed like there was a pre-screening that happened before that that limited these sites to only 7 that PC chose to do an assessment of. And so I was wondering why there was that pre-screening step that really limits what the amount of projects that PSC is looking at rather than looking at what's technically feasible first and then selecting sites from there. So that was back on slide 21. I don't know if we'll revisit it or if there's a better place to ask that. But that was my question. Thanks.
Yeah, to clarify, the 7 projects are distinct from the DuPont projects. So apologies if that was unclear. We looked at all of the DuPont pipe in this analysis, which is that 165 miles. And then there is an additional 7 large projects that I'll be showing the results for after this, as well as I mentioned, a handful of other smaller categories of known investments that PSE are looking at. Does that help clarify?
I think so. I guess I was just wondering how the 7 projects were selected and if those were screened before the technical assessment.
Yeah, I'll just say that they're separate from the technical assessment progression shown in this section. And then I would invite Nisi or David to describe where the 7 projects were derived from.
Yeah, and I can either do that now or I can do that when we get there. But essentially, when we look at our system needs, we have projects that are over $15 million that we know. Well, we don't know if the project is going to be over 15 million, but we have large system needs of things that we know we're going to need to address. Maybe it's a federally required MAOP reconfirmation, or there's something on the system that we've seen. And so that's where we selected those projects that we know we're going to have to do something with, even if we haven't decided what we're going to do with it. The only caveat I have is if we thought that our non-pipeline alternatives could be done without needing any customer-sided electrification or anything customer-sided, we didn't include it on the list, so we have 1 additional project. But these are really our larger projects for those 7.
Got it. Thank you.
Great, thanks for that question, Megan, and for popping on Nisi and David. Dan, I don't see any other questions, so I'm going to invite you to continue. Thank you.
Great, thanks a lot for the questions. Yeah, just to wrap this section up with what we concluded looking at the DuPont program is that approximately 4.5% of the DuPont mains are in that less than or equal to 5 connected customers and technically feasible and economically beneficial. And about 30% of the sites are in highly impacted communities. So this is just an initial, as David described it, top-down screen. To do an implementation of these projects, you would need to look in more detail at specific site conditions. Things like, do you need additional service line or system upgrades, electrical panel upgrades, as well as importantly, of course, customer willingness to convert. And then I'm just reiterating that the achievable potential is likely a smaller, uncertain share of that number, given the challenge of universal customer conversion for any zero gas project. So that's the terminal branches, but there's also this larger inventory potential system impact segments that would require further hydraulic modeling from PSE, which could also achieve savings and have less than or equal to 5 customers. So those could also be a population that is worth targeting. And just noting that the analysis we developed here is a first of its kind, and we're delivering materials to PSE that allow them to use and refine this analysis on an ongoing basis and use it to deploy target electrification when they're ready and able. And then again, noting that we looked at other inventories that are much smaller than DuPont. Categories include low pressure mains, farm taps, inside regulators, where we also identified potential cost-effective NPA opportunities. So with that, maybe we can move to the next section, which are the specific projects. And these are going to be the 7 specific projects that we were just briefly talking to. If we go to the next slide. So these are 7 large projects, as Nisi mentioned, that PSE are considering. And we classified them into 2 main categories, as shown in the type column of the table: peak and zero gas. So I'll start with zero gas. Zero gas projects are similar to the DuPont projects, so they're much larger in that they require total customer departure in order for them to be avoided. So you need to fully remove all customers from service to avoid the gas investment, which means you need to fully electrify the building, every appliance in every building. Contrast that with peak NPA projects, which do not require 100% customer departure. They require something less than that. These are typically projects where they're all projects rather, where the goal is to reduce design day peak demand below a certain threshold. And what we're really looking at there is space heating electrification as the primary strategy to do that. And we're looking at space heating electrification as the main strategy rather than, say, cooking or clothes drying or other uses of gas, because the vast majority of gas on a peak day is being used to power furnaces and boilers. Next slide, please. These 3 columns, shortfall, established project date, and project cost, are showing key features of each project. The numbers kind of jump around, but I think the important thing to understand is that for each project, you need to meet the shortfall in standard cubic feet per hour by the project date in order to avoid the costs shown in the final column. And so there's a wide variety in the size of the projects and the dates, as well as the avoided costs, but that general need and is what we're trying to solve for here. Next slide, please. What this is showing are the composition and counts of the customers served at each of these specific projects. So as you can see, they're very large projects with thousands, or in some cases, hundreds of thousands of customers. Most of them have a split of residential, commercial, and industrial customers. 2 things to note about that customer composition: the residential and commercial customers change in ISP scenarios, particularly ISP load scenarios with different levels of electrification. That does have some impact on the analysis for reasons I'm happy to answer questions about as we go on. But ultimately, we're showing the reference case because it didn't change the results when we looked at those sensitivities. And then the presence of industrial customers is also something to note. Those are customers where is, generally speaking, going to be harder from either a technical or economic perspective to fully electrify them. They may have processes that are high heat or that are otherwise not well suited to electrification using existing technologies. Next slide. Okay, so the previous slide was showing the total number of customers in each site. What this is showing in the final 2 columns are, first, the customer adoption needed in order to achieve the demand reduction that would allow the project savings to be achieved. So that's total, that's like in terms of thousands or tens of thousands of customers to participate, as well as in the final column, what that means in terms of the annual share of customers that would need to be converted at each site in order to meet the need by date. For projects 3 and 6, these are zero gas projects where you would need to electrify every customer in order to avoid the investment. And given that 5 customer adoption threshold, as well as just the really rapid pace of just overall electrification we need, these projects are almost certainly infeasible. The other projects still have a very rapid rate of customer adoption required, even if they don't require 100% adoption. And I'll contextualize what that looks like relative to what we've seen in terms of heat pump adoption in the Northwest in a few slides. Next slide, please. And this slide adds 2 more columns that show the cost effectiveness results for these projects. I'll start on the right, which is the utility net cost. These are in levelized costs, so it's all annualized values. And what we're seeing is that from a utility cost test perspective, each of these projects it carries a net cost. And I'll unpack why that is on the next slide. From a societal cost perspective, we're seeing one project is societally cost effective, and that's project number 2. Next slide, please. Zooming in on project number 2, we can give a sense for why these projects differ in their, or why these cost tests differ in their outcomes. So in the utility cost test, what you see is in the top, the costs, on the bottom, the benefit. The costs, as you can see, are driven primarily by that big gray utility incentives block. And the assumption we used here is that PSE, in order to achieve the high levels of adoption assumed here, to avoid the investment, would offer the full cost of electrification as the incentive to encourage this project. So, that's approximately over $20,000 per residential customer and around $150,000 per commercial customer. There's also electric system costs included in there, such as electric supply costs, generation capacity costs, and transmission and distribution costs. Talk more about the T&D in a minute. And those are contrasted against the benefit, which is the cost of the avoided cost of the gas project, and which in this case is about a little bit less than $1,000 per year. Sorry, $1 million. The total resource cost test, sort of a modified total resource cost test, has a different set of outcomes for a couple of key reasons. And it really can be seen on the bottom, on the benefit category. The first is that this is not looking at the incentive cost, but rather it's looking at the net cost of appliances. So you can see in the darker blue on the cost that there's still that big upfront behind the meter capex for electrification, but that's offset to an extent by the fact that you're avoiding replacement of your existing heating system. And the other big difference is that this cost test perspective includes a monetized benefit of avoided greenhouse gases and that green wedge, which combined with avoided gas commodity costs and the avoided gas project costs push this project into slight net benefits. So I think this slide for project 2 illustrates why we had that difference in outcomes, and I think also helps to unpack how these different cost perspectives are applied across each of the projects. Next slide, please. We also did a bit more of a detailed analysis looking at the impacts of these 7 projects on electric distribution costs. So we worked with PSE's electric distribution planning team to determine which of these sites would be most likely to see upgrade requirements from electrification, and identified 3 projects 1, 2, and 6, as sites that warranted additional analysis. E3 developed an incremental electric peak demand forecast drawing on the NREL, RESDOC, and Comstock building simulation databases, and applied those at a substation level for each of these projects. And so what the graph on the left there is showing is for each substation and each project, in the light blue, what the headroom is on the system in the winter, in dark blue, what the projected impact on peak is, and then in red, cases where the dark blue projected impact on peak exceeds the remaining headroom. In cases where we identified an incremental upgrade cost, we applied a range of overnight capital costs for primary and secondary distribution upgrades, and those were applied to the subset of projects for which we identified a potential need. Though, as you recall from the previous slide, it turns out that these costs are relatively small compared to other costs, including other electric costs, though they are still material. Next slide. All right. I mentioned that I would contextualize the adoption results for each of these projects against historical experience. So what E3 did is we took a look at the RBSA building stock inventory that NEA puts together for the Northwest. We looked at the 2017 edition and the 2022 edition and estimated that a little bit less than 2% of households per year are adopting a heat pump in Washington State and within PSE's gas service territory. And contextualize that compared to each of these projects. So what the x-axis shows you is the annual conversion rate of residential customers for each of the projects that we looked at. On the low end, you have project one that would require a little bit over 6% of projects to be, or 6% of customers to be converted each year. And then project two, which has a little bit less than 17% of customers that need to be converted each year. And so what that means is you would need to approximately triple or increase by nearly 9 times the rate of adoption at these sites in order to get sufficient demand reduction to avoid the project. So it puts it in contrast that it would be quite challenging from both an economic, I think, and a adoption feasibility perspective to pursue these 7 projects. Next slide. So as I mentioned, there's some challenging outcomes from these 7 projects, both in terms of just the level of adoption and the pace of adoption that would be needed, as well as the cost effectiveness. So the cost effectiveness outcomes, again, were driven in large part from the UCT perspective, utility cost test perspective, by the large customer incentives that were assumed to be needed to achieve adoption, as well as incremental costs on the electric system. But including avoided emissions does improve the cost effectiveness picture for all the projects and pushes one of them into net benefits. And so with that, demonstration that there can be benefits from these projects, it is probably worth continuing to pursue them where they're close to having benefits for a variety of reasons. On the one hand, for example, in Duval, you're learning what it looks like on the ground to deploy a non-pipeline alternatives program, getting a better sense for how big the incentives would need to be, how customers respond, and what strategies will work better than others. I see hands, and I'm at a breaking point, so I'm happy to stop and take any clarifying questions.
Thank you, Dan. Actually, we are going to do questions in the order that they came in. So Lauren, if you could just hang tight, I'm going to first direct Dan's attention to a question from Dennis in the chat. And this question has to do with slide 22. So Jack, if you could back up to slide 22, please. And Dennis's question is, have you quantified the potential incentives and net benefits in financial terms?
Yes, we have quantified both in financial terms, included for the benefits shown.
Okay, thank you. Quick response, Dennis. Is there any follow-up to that, or does that answer your question? Sounds like that answered the question. Okay, the next question has to do with slides 26 and 27. So Jack, if you could move forward to slide 26, please. And this is from Sophie. It's related to Dennis's question. Is the UCT cost-effective test on slides 26 and 27 equivalent to joint utility cost effectiveness on slide 22?
Yes.
Yes. Okay. And can dig into what goes into that cost test a bit, just briefly.
Yeah, it includes incentives, electric system costs as costs in the test, and it includes the avoided gas infrastructure cost as a benefit.
Great. Thanks for that question, Sophie, and for your response, Dan. Okay, Lauren, go ahead.
Yeah, I don't really know where to start. I'm having a very hard time following this. You described it at the beginning as a first of its kind study, which is worrisome to me. And I guess without any basis for understanding the methodology, I kind of feel like we need to back up and just level set about what the methodology, how was the methodology developed? What other work have you and your firm done along this scope? And where can we look for sort of other examples of where this type of study was done and the results of those studies? I mean, I know E3, I know you guys are reputable and all of that, but it's new to us, it's new to this group. You said it's first of its kind. And so that to me just means we need to take some time to kind of understand how this is being done. My first impression is that these projects seem really large. And so I'm wondering why maybe some smaller projects where I would feel like the cost effectiveness, some of the challenges in heat pump adoption, et cetera, might be a lower barrier. I'm wondering why those were screened out. So I don't know. I'm sorry if this is like coming out of left field, but I was trying very hard to track this and having a hard time. So I just felt like I needed to speak up.
Yeah, one thing I'll note is we've published previous work in the space. There's work in California that we've done on behalf of the California Energy Commission, NRDC, PG&E that we could
Great.
point you
Could
to.
you like maybe put a link to that in the chat or send us those studies or something so that we can
Yeah.
get smart
Okay.
on this? Yeah, thanks.
And then on your point about screening out small projects, just clarifying, we did not screen out small projects. So we had the initial discussion on DuPont, which are small projects that have lower adoption barriers, and indeed found a more cost-effective population of opportunities and a higher adoption feasibility set of opportunities. And so that last section I presented is just 7 specific, very large projects that have their characteristics that make them really challenging, but that was not the limit of our analysis.
Okay, yeah, because when I was looking at that list, I mean, sorry, that's not the slide that's up here now, but I mean, I wouldn't expect Puget to jump into like a 20,000 customer electrification project right now. I was kind of thinking more if you could go to the slide that has the customer numbers, like I feel like I would be more interested in seeing some of the smaller ones. So for, yeah, just in terms of feedback, that's my feedback, I guess.
Yeah. Thank you, Lauren. And it sounds like there are some studies that can be shared with you and everybody on the RPAG. So thank you, Dan, and Dan's colleagues are working off screen to pull those studies together, and we'll bring them forward. So thanks for flagging that. I see 2 more hands raised. I'm going to pause for a second and see if there's other members of the RPAG that have questions that haven't had an opportunity to ask yet. I just, in the interest of making sure everyone has a chance to ask questions, and then we'll take 2 more quick questions and then we'll move on in the interest of time. Are there others on the RPAG who haven't had a chance to ask a question? Okay, I'm not seeing any. So Sophie and Dennis quickly, and then we will move on.
Okay, well, first, thanks for the answer on the question about the cost test. Just quickly on that, statute does specify that the social cost of greenhouse gas emissions needs to go into the decision making for the ISP. So I'd be interested in having a conversation on why that wasn't included in the utility cost test portion, as well as CCA costs. But for my question, on the more recent part that you just talked about, the 7 projects, it sounds like what has been focused on is full electrification of these large populations in those 7 project areas for the non-zero gas ones. Has E3 in their analysis looked at other forms of non-pipeline alternatives, such as demand response or anything else?
No, for the purposes of this analysis, we looked only at electrification. We did, in the early phases of the analysis, consider things like building show retrofits and DSM, but those measures don't have really big enough energy savings to meet the demand reductions that PSE would need to achieve to meet their target, or at least not at a level of adoption that was possible. And then I'll maybe let Nisi speak to other forms of NPAs apart from customer-side solutions, if you would like to, Nisi.
Sure. So we have other options that will be that are being considered depending on the project and what the need is. But a couple of projects are related to our transmission requirements, and so we can reduce pressure, we can do other things. Today we were just with E3, we had them focused truly on the customer sided ones. And like you said, early on, we were thinking weatherization, we were thinking, we have looked at demand response in the past, but those items either aren't mature or they just require such a volume that we couldn't get to where we needed to, so we limited the scope for this analysis, but may include it going forward.
That's helpful. Thank you, Nisi. And I just want to echo, I guess, Lauren's question about why this size of projects, and if you
Yeah.
could say anything about why they couldn't be broken down into smaller projects, or if you considered that.
Yeah, so it's interesting. We have a habit over the years of trying to minimize the investment we have. And so we hold on to but our normal practice is, can I keep the area doing cold weather injections, doing other things, or doing smaller projects? And so then by the time I take action, sometimes they've gotten big because I can no longer maintain because they've been growing for years. And so one of the things I think you might see is that we're kind of in a change of where we're heading. So these are the things that we see. Well, really, we should be, and maybe as the future kind of continues, now that we don't have growth and we're looking at what the system happens, with those opportunities, you identify them earlier and you address them. What you're seeing now are the opportunities that we've been held on and trying to wait, and do we really need to do it? And by the time we show it, we actually need it. And that's some of the things I think is trying to be addressed by the law, that's saying, even if you don't know what you're going to do, but you have an idea, there's something, you need to start showing that. So I think that's that opportunity, but you're kind of catching us up. We're still transitioning from that old methodology.
Thank you for coming on, Nisi, and addressing that, and great question, Sophie. I'm going to go ahead. Dennis, thank you so much for your patience. I'm going to go ahead and call on you to ask your question, and then we'll let Dan finish up. We're running a little over time in this segment, but this is really important information, so we're doing it knowingly. Go ahead, Dennis.
Thank you, Hillary. I just want to apologize. I wasn't able to hit the button properly to be able to make my comment at the appropriate time. So I will make it now. I said, yes. What are the numbers? And two, can you compare incentives and benefits of the other studies that were mentioned to give a relative financial rating? And this is projects that were just listed here recently.
No, just to clarify, is the question, what were the incentives we assumed?
No. I want to, with the projects, you said you had a list of projects that you could reach out to that would also be similar to what you've done here. And I'd like to be able to see where, the benefits are from those other projects and this specific project that was mentioned. Did I understand that properly? There were additional projects that were done that staff is reaching out to look at as comparison?
The other projects I mentioned were other E3 projects, which were similar to this studies of the opportunity. They're not programs that have been deployed, so there aren't sort of realized incentive budgets. There are utilities that have deployed such programs. If you're looking for examples of what that's looked like, I think the report that we cited from RMI and National Grid offers a really fairly comprehensive review of these programs, at least through 2024. And there's other utilities deploying them throughout the US right now.
Okay. But leading back to the first question, yes, I would like the numbers of those basically those delta areas, potential incentives and net benefits.
Yeah. So we've made assumptions about what the incentives would be, but that isn't necessarily but that's for the purposes of getting that cost screen. So I think we used incentives around $20,000 per residential customer, and I think $150,000 for a commercial customer. Those are in round numbers. And then as far as the net benefits, we've shown that in that map, and there may be other data that PSE could provide whenever they're ready.
So you're saying these are all assumptions then?
Yes, it's all an assumption-driven exercise.
Thank you.
Thanks for that question, Dennis. we are already running over time on this segment, but we're gonna go ahead and push it to 2:15 and take a little time out of the next presentation. These are great questions and important questions and important information. So Dan, I'll hand it back to you to continue, and we'll have till 2:10 and then we'll pivot to the next presentation.
Great. I seem to have lost the screen share. There it is. Great. All right, if you could advance to the next slide. Yeah, I think we had a lot of interest in the relative cost effectiveness of these different projects. I'll go through this in pieces. I think one thing that's really important to understand about the DuPont versus the specific projects is the cost savings per customer you have to electrify. So what makes the DuPont projects more likely to be cost effective is that there is more gas system cost per customer that you can be avoided. Those blue bars show on an annualized basis what that looks like. So you see we have on the x-axis anywhere from 0 to, I think on the far right, $15,000 per customer annual avoided cost. The green bar shows the levelized residential equipment cost that we assumed in this analysis, which you could think of as sort of an annualized mortgage-like payment for a heat pump, which are about $1,800. And so there's a lot of parts of the system where a DuPont replacement will happen where the avoided costs are higher than the avoided costs of the gas system are higher than the cost of electrification. That contrasts with specific projects, the bigger ones, where the savings per customer are on the order of $0 to $1,000 per year, which is significantly lower than either the residential or especially the commercial equipment costs. So it just demonstrates that there are some projects that are going to be more cost effective on a dollars per customer basis than others, and this analysis, I think, unpacks that. Next slide. Just a few sort of qualitative conclusions from the work and open questions. I think this work has demonstrated that achieving target electrification to achieve non-pipeline alternatives faces challenges in terms of customer adoption. So both 100% opt-in for the zero gas projects and then just very, very high rates of adoption for the specific projects. There are uncertainties in NPA funding. So how NPA costs would be allocated and funded is an open question. Part of that, we'll need to consider how any avoided gas replacement costs are used. For example, should those costs be used to help support electrification, or should they be returned to gas ratepayers to defray gas system cost pressures? There's questions around how the electric distribution upgrade costs should be used, and then also customer prioritization. Thinking about, do you just sort of prioritize the most cost-effective places? Do you aim for more equitable allocation and targeting disadvantaged communities and other priorities you might consider in ranking potential opportunities? Next slide, please. So in sum, for the planned DuPont replacement projects, terminal mains with a relatively small number of community-connected customers represent a promising starting point for target electrification projects, especially that 4.5% that are both potentially cost-effective and hydraulically feasible. For specific projects, there are challenges from both a cost and unprecedented rate of consumer adoption perspective. Customer incentives may need to be very large to make those projects possible, even if they are possible at all. And so taking those two together, E3 concluded from this analysis that pipeline replacement project NPAs like the DuPont projects present a relatively stronger opportunity for PSE to successfully deploy target electrification in the near term. Or, following from the conversation we had today, really looking at smaller projects rather than the really big ones is probably the more promising place to start. So I really appreciate everyone's time and attention today. I understand this is a kind of a new topic and it was a ton of information I threw at you today. I don't know if there's time for any remaining questions, but I'm certainly happy to answer any if there is.
Yeah, Dan, thank you so much. I suspect there are more questions. I see a few in the chat. In the interest of time for now, we are going to pivot to the last couple slides of this segment, which Nisi is going to present. And then we're going to kind of figure out how to make sure the remainder of the questions can get addressed. So thank you, everybody, for your patience, for those of you who asked excellent questions. So just stay tuned. We're working behind the scenes to figure out how to get through everything. Nisi, go ahead, slide 44. I believe we're on.
Okay. So I think if you're thinking, well, how do we use this analysis? I see some of that, is this, how are we going to use it? Where is it going in? What is this? Really, it gives us a framework to continue our non-pipeline analysis perspective that we've been kind of doing from the last rate order, but it adds a lot more structure. It advances our cost effectiveness calculations. One of the things, just to kind of clarify, we are looking at all three for the examples that they gave today. They talked about the utility cost test, but but we do actually have included the social cost of carbon. When we're looking at it, we're actually trying to look for those opportunities that give us the best chance. And so we're just trying to learn at this point. And so don't think of it as we're trying to be as exclusive as we can. We're actually trying to be as inclusive as we can. We're trying to see, does it pay off in any of them? And if it does, then let's talk to the customer and actually try to get that going. So this is really to kind of help us understand where geographically targeted electrification may be feasible, and the impacts it has on the system. And we want to just kind of incorporate it into our larger non-pipeline alternatives. I think Jen's going to follow up real quick after me, but I know there's questions of, is this the only electrification? This is really about that geographic electrification as defined as it's the cost-effective approach, instead of doing cost-effective, being able to defer capital and large operating expenses. So that's really where we're narrowing it. There are other things in the ISP where we looked at electrification. Next slide. And so we have a whole bunch of work to do after this, but what we're going to be doing is we're going to be looking at those opportunities, and we're going to be looking at those opportunities and seeing what they are and kind of true that up with our bottoms up approach. So, if you think about it, this was giving us a net. Now we have to start looking at them in detail as we go to delivering those lists of 20 years worth of projects of what we know. And so this is kind of the action item. So this is more of the beginning and not the end. And I didn't see all the questions come in, but I saw one, Lauren. No, the DuPont is referring to Adelaide HD pipe that was manufactured by DuPont. And it's a known risky pipe in the
High risk pipe.
Yeah. Yeah, it's a known high risk pipe. Okay, any questions? Hillary's going to send out a poll later and ask you guys for feedback. Is there anything?
You see that there's a lot more in the chat. I suspect other people have questions. We are at time, I think.
Okay. Yeah, sorry, Hillary, go ahead.
Looks like she cut out.
I think we lost her. Well, while we wait, before we jump into the next section, I know that we're pressed for time. I thought it'd be a good opportunity with the confusion about the electrification. So at a high level, so that, as Nisi mentioned, like we're doing electrification at a few different points. So there's the high level view of the integrated system plan where we're looking at electrification through the scenarios. And we're actually going to talk about the demand forecast associated with those electrification scenarios in a couple minutes. So that's looking at the portfolio level. And then what Nisi was talking and Dan walked us through today is, as she mentioned, a portion of that from the gas system perspective. So looking at a targeted electrification based on the pipes themselves and where or the condition of those pipes, or what investments need to be had, and how can we best look at cost effectiveness from a capital investment avoidance perspective and electrify customers. Then there's also electrification from a general electrification concept of cost effective in more of a traditional sense that we're looking at, as well as we have the electrification pilots going on too, to test customers' responsiveness to different incentive levels and those sorts of things. So we're kind of doing this from a top down, bottoms up, all of it, because it's new and we're trying to learn as much as we can to understand what the different levers are. So hopefully that's helpful. This is just one magnified piece of the pie and a part of the requirements to evaluate this a little bit deeper. So hopefully that helps. And I don't know if we got Hillary back or not. Oh no.
Jen, I don't think we did. We might have to
what will we do?
figure out how to do this without our facilitator. So for our next topic,
Yeah, is oh.
Nick,
Oh, there we go. Okay. Yep.
Okay. All right. Next slide, please. I'll introduce myself. My name is Lauren Molander, and I am the manager of Puget Sound Energy's load forecasting group. We've come to the RPAG several times over the course of the almost 2 years that Jen was talking about earlier. We are here today to talk about an update to the electric reference case demand forecast, as well as the ISP load scenario results. Next slide, please. Okay, so today we are seeking initial reactions to the results of our demand forecasts, our scenario demand forecast specifically. Are you surprised by anything? I will say that our involvement from an ISP perspective compared to an IRP perspective, there's been a lot more work done by the load forecasting team to prepare all of these different scenario forecasts. So it's first time for us to have that many deliverables in an IRP ISP situation, and always welcome to hear methodology feedback for the next planning cycle. Next slide, please. Okay, as I mentioned, we've been at the RPAG talking about demand forecasts for a number of RPAG sessions. I will say that the forecasts, the demand forecast scenarios are really a culmination of a lot of different work by different groups, a couple of different consultants, as well as my group. And so we've talked about bits and pieces so far. We've also had a couple of different presentations on the reference case itself. I'll note that we talked about the reference case in July of 2025. And then we came back to an RPAG that's actually not on this slide, but March of 2026, we showed an update to the demand forecast reference case. If you recall, we lowered gas growth, just seeing recent trends. Gas growth came down, as well as lowered expectations around EV adoption, just given what we were seeing through the end of the summer and into the winter with federal tax credits going away and state policy pausing. So we'll see a couple reminder slides of those, but next slide, please. And next slide. So the first several slides I've got here, well, actually, before I dive into the demand scenario forecasts. Okay, so this is an update to our reference case electric forecast. And it's relevant to a very particular assumption that we have in our modeling process, that is the line loss factor. And what losses are, if you're not aware of a line loss factor or line losses themselves, it's literally like the electric physics. Electricity is lost through transmission and distribution lines and the transformation process. So we model delivered load, which is what the customers use at the meter. But in order to serve that delivered load, we have to gross up the amount of delivered load that to get the amount of energy that has to be generated or otherwise acquired to serve that load at the meter. So the loss factor is something that we receive from our accounting department, and we were advised in April of this year that they had looked at the line loss factor that we'd been using, and they advised us to adjust it down. So when you saw the results of our reference case demand, we were using a 7.58%, and we were advised to lower that to 5%. The results of doing that is essentially reducing electric load and peaks by 2.7% just across the board in all years of the forecast period. So it just is, we don't have to gross up the delivered load by as much to get that total load. Again, this only applies to system load and peaks, and it doesn't apply to gas. And it doesn't apply to gas customer growth in general. Just that grossed up value. I should note, important note is that in May you saw some portfolio results from the reference case. The reference case demand forecast was used for that. It included this update. This was an update that we got kind of very last minute before all the portfolio modeling had to begin. So we got that update in there, wanted to reflect the latest and greatest information that we had. We were able to do that. So any of the results that you're seeing that use the demand forecast as an input already have this update incorporated. One last note, and then we'll get into the demand scenarios. I haven't asked about why they're decreasing. It is kind of interesting. This is one of the assumptions that has been pretty stable in my tenure of doing this kind of work. And over the last few years, as energy accounting was showing us, the line losses appear to be decreasing. I actually don't know why that is. I don't have a good answer for us today. It's something on our list that we are continuing to research and understand why this might be happening. And we'll continue to evolve the assumption as we learn more. Okay, in an effort to save some time here, yes, let's get into the ISP load scenarios. Okay. Next slide, please. And you'll notice that the first few slides we've seen a number of times in our various RPAGs up to date. And this is just remember to set the stage and remember the context of the scenarios themselves and why we're doing them. But the reference case is meant to be business as usual. And then the various scenarios have been defined to study what it would look like with more and more electric load. And what that would mean is less and less gas load. What are all the possibilities there? Okay, next slide, please. This is the table full of lots of words that we have also seen along the way quite a bit. And this is just a reminder slide about, what's in the reference case and what's in S1 through S4 is what we're calling each of the scenarios. There's really 4 main components that we have levers that we're turning and studying different assumptions: building electrification, large loads, customer programs, and EV adoption. And we'll kind of dive into this a little bit more on the next slide, please. This slide about large loads and electric vehicle scenario assumptions, we did present this at the March 26 RPAG. These are a couple of slides that we showed you back then. Essentially, we walked through what our assumptions were to come up with a higher load assumption for large loads. And a lot of times people are thinking about these large loads as data centers. Came up with a way of an assumption for something higher than what we currently assume for our reference case. That's on the left-hand side. On the right-hand side, we're just reminding you of a slide about the EV high adoption scenario. Because again, each of S1 through S4 are looking either reference case EV adoption or high EV adoption. So, and we'll, on the right-hand side in very small print, just again, a reminder, we had lowered the reference case to be the low. What we had is originally a low EV adoption, but that's one of the updates that we made in March. But we are still testing the high EV adoption in these scenarios. Okay, next slide. All right, so this is the one I want to get into the meat of a little bit, because I think this is really where we have a lot of nuances in the various building electrification assumptions. So we've got the reference case plus 4 scenarios, and really reference case is reference case. Scenarios 1 through 4 are testing 3 different assumptions around building electrification. So just walking through this so that we know what we're looking at when we're looking at the results, because building electrification is really the primary driver of these load differences in the scenarios. So scenarios 2 and 4 have the same assumptions for building electrification. And that is starting in 2030, buildings are being electrified at a pace that brings the emissions of both utilities below the utilities' proportional share of the greenhouse gas emission goals. So 2 and 4 are meant to be high aggressive building electrification scenarios. Scenario 3 is very, very similar in that it's a pace that brings the utility both to that greenhouse gas emissions line. However, it is constrained by equipment failure. So as people's furnaces are dying, and then that's when we would they would replace it with an electric heat pump. So scenario 2 and 4 seem very, very similar, but there is a difference. 2 and 4 is that scenario 2 is analyzing the increased, more aggressive pace of building electrification only in terms of those other assumptions. Scenario 4 is analyzing the aggressive building electrification, but also the high large loads and the high EV adoption. So more load because of those other things as compared to scenario 2, where it's building electrification high, but reference case for EVs and large loads. Okay, and we have little cheat sheets up in the right-hand corner, if that's a lot to remember, because I have trouble remembering all that when I'm looking at these. Okay, next slide, please. Okay, so results. This is system load. We've got electric on the left and gas on the right. Looking at the electric load on the left, this is expressed in average megawatts. We've got the reference case on the bottom in that purple line. And as expected, with each of the scenarios, we increase in electric load. S1 is higher than reference, S2, S3, and S4. On the right-hand side, we've got gas. We've got the reference case at the top, because again, gas loads in these scenarios is being reduced. So we've got S1 down there, kind of below the reference line, and S3, S2, and S4 are down there at the bottom. I'll just make a couple notes on this. Scenario on the reference case on the gas side, the reference case is declining. It's declining. There's a little bit of building electrification already built into that reference case. But remember, we also have climate change, and those warming winters overall is driving overall average heating down. Gas is so sensitive to heating. And so we do start with a declining load on the reference and then continue to add on that more and more building electrification. Same thing on the electric side, we've got that reference case. I want to just note it's increasing slightly, and just to remind you about reference case and why that is. Growth is being driven primarily by EVs. So we do have a bit of positive growth on the reference case, and then of course, the scenarios are adding on the various assumptions that we just talked about. Okay. I think I'm going to show you the peak slide, and then I see that we have a question. So if we go to the next slide, and then we'll take a question. This is peaks. It's the same idea. On the left, we've got electric, and on the right, we have gas. It's very, very similar in nature. We've got S1 being slightly more than the reference case on the electric side, and a little bit more impact down there on the gas side. But largely overall pretty similar to what we would expect and what the what the load scenarios look like. And I will pause there for a question. Katie, you have your hand up.
Thank you. I'm just noticing that obviously here, the first 10 years or so are basically tracking the scenario 2, 3, and 4, and then there's a divergence. So I guess in defining the scenarios, there's equipment failure. I'm a little bit unclear like how that's defined in terms of the timeline of a customer's, something breaking down and needing replaced. Maybe that's, I guess I'm just unclear like how that creates the divergence, and maybe you can sort of take that and apply it to 3 and 4 as well.
Yeah, and I'll just start with a simple statement, and then Taylor has he's come on camera. He is from Cadmus, who was the modeler for the building electrification impacts that we're seeing here. And that was presented, the methodology, I should say, was presented back in February for building electrification. So there is some detail back then, but I'll just say that all of the building electrification assumptions really start in 2030. And then for the divergence, more in the 2035 timeframe, I'll turn it to Taylor to take that.
Yeah, sure. Yeah, so equipment failure is really based on the effective useful life of various pieces of equipment. So heat pumps, for example, I don't have the number off the top of my head, but we are getting those data from the regional technical forums analyses, and it's consistent with the Northwest Power and Conservation Council power plans as well. So we have a turnover model that's not a simple version of which might be if something is expected to last for 20 years, you might approximate that 1/20 of the stock fails every year, so about 5% fails a year. And that's not exactly what we use, but it communicates the right principle. So there's kind of a trickle of these replacements that occur every year. And we assume that most decisions are made in terms of whether someone wants to upgrade or convert. They make them at those junctures when they're facing some capital cost either way, because they either need to buy a new furnace or convert over to a heat pump. So that's the failure constraint that's limiting scenario 3. Scenarios 2 and 4 do not have that constraint, and the reason why they track pretty much exactly with scenario 3 is because they're all assuming that all equipment that fails is converted. And scenarios 2 and 4 additionally assume that still functioning furnaces and boilers and other gas equipment are removed from the stock in sufficient quantity for PSE to bring the carbon emissions for both their electric and gas systems below some assumed proportional amount of emissions for the two utilities. It turns out that through our modeling, up until whenever that diversion point is, 2035 or 36, PSE is actually already under that amount under the scenario 3 assumption. So that's why there's no divergence really between those three until that point. And then they diverge because the total kind of greenhouse gas reductions does diverge between the 3 scenarios based on some of those additional load differences, in the large load assumption and the EV assumption and so on.
Really helpful. Thank you.
Yeah, thanks, Taylor. And this is Hillary, and I am back. I got bumped out of the meeting, so apologies for that. But I do see another question from Byron. And Lauren, if you don't mind taking a question from Byron, go ahead, Byron.
Hello, this is Byron from the Washington UTC. I think this question will probably also be for Taylor as well. So I guess I have a handful of questions related to these. So the first question I have is has the company looked at the associated bill impacts with these scenarios? So like just kind of firing from the hip here, if we have about a 80% reduction in customers by say like 2042 for scenario 2, wouldn't that be a five-fold increase in the bill impacts associated with system fixed costs? Like I say, like are customers going to stick around in a situation like that? Is that a plausible outcome? Like, is that a energy burden crisis that we should be aware of or planning for?
Taylor, do you want to talk to a little bit about the assumptions in the model about rates and how that model incorporates?
Sure. And I might ask Jen to
Y-
be kind of on deck as well.
Yeah, I think this might be a little bit of a twofold question.
Yeah, so we did touch on this, the rate question and the kind of dynamism or maybe lack thereof inside the building electrification modeling around this point. So in the building electrification modeling, we are using the rates published through the 2023 decarb study. We talked about back in the methodology meeting, I think back in February, about the kind of iterative nature. There's a lot, that goes into the exact determination of rate impacts. It's kind of, one of the main objectives of the ISP planning process. So after this current cycle, for the next analysis, we would use that kind of the latest rates from this current scenario planning that we're doing now for the next cycle of analyses that would show, in those near full electrification scenarios, that there's absolutely going to be a point where, the gas costs just balloon beyond any amount of reasonability. Jen, I don't know if you want to layer anything onto that from your side.
Yeah, sure. So these are the demand forecasts. These aren't the results of the analysis, to your point, Byron, regarding the cost and the impacts of these scenarios. So that'll be forthcoming in August, and we'll have a view of what the impacts of these different scenarios might look like, based on the modeling assumptions that we have. I think it's also important to note that the electric system in those situations more than almost double as well, right? So there's impacts on both sides. So it's important, and why we're doing the integrated system plan, to look at both sides. So that'll be forthcoming, and we'll have more information, hopefully in the next RPAG.
Okay. And in terms of meeting state GHG emission goals at like the lowest reasonable cost, does the company consider any alternative fuels like hydrogen or say like renewable natural gas as part of that portfolio? Or is the company effectively saying that decarbonization is an appropriate pathway here? Is that an accurate takeaway?
These don't have, this is just looking at the demand. So this is looking at the gas utility demand in this scenario with these planning assumptions. What would that energy demand for those customers be? So we're not looking at how we serve it. We're just saying this is what customers would want. And then once we model it, then to your question, we'd be evaluating different impacts.
Okay.
But right now, to more further answer your question, we just have renewable natural gas. We don't have hydrogen in the gas.
I really appreciate that clarification. So I guess to iterate on that, would that mean that hypothetically later on, we might assume there might be another scenario where the company says, okay, we're going to try and lower our emissions in line with state emission goals, but see a balance of electrification and alternative fuels to see which is like the most cost-effective pathway?
I'm sorry, I'm not totally, I didn't follow your question. Can you ask it again?
So if we kind of like pin the goal of meeting state GHG emissions as like a scenario outcome. So like that's a scenario outcome you guys have highlighted with scenarios 2, 3, and 4 of like this is something that's like an outcome is we want to reduce emissions. But as you've noted, these scenarios 2, 3, and 4 only look at electrification as a means of meeting those goals. Should we anticipate that there will be future scenarios down the line that the company looks at where you look at a combination of both decarbonization and electrification as a means of meeting state emissions goals.
Yeah, so decarbonization would be factored in when we actually do the portfolio analysis. So again, this is the challenge, is that there's a reduction on the gas and an increase on the electric, right? They're connected. And so the intention was to look at these scenarios together to understand the decrement on the gas side and the increase on the electric side consistently across those time periods. So then when we run them through the portfolios and we have all of those different options that you kind of talked about, we can see what those impacts would be, if that makes sense. So I think what the answer to your questions is there's more forthcoming to help clarify this for you.
Okay, great. I appreciate that. I look forward to that. And I guess the last question I have, and sorry,
Byron, I'm going to interrupt you for a second.
Okay.
We're running out of time here. We have a couple more questions in the chat. And since they're related to this slide, please be patient. I just want to make sure everybody has an opportunity to ask questions. Elisa has a question about this slide, and it is whether the EV load is managed. The EV load is managed charging assumed in this table.
Yes, and I did put it in the chat that, yeah, the peaks and the loads shown here on the slide do reflect demand side resources.
And you said, I think in an earlier slide, that it was scaled to the level of load growth as well.
That's right. Yeah.
Okay. I just wanted to make sure I solidly understood that. Thank you.
Sure.
Yeah, thanks for that question. And then JP has a question about what explains that S2 achieves the same peak gas level by 2050 as S4, but does so with 10.7 gigawatts instead of 12.5.
Yeah, I posted the answer in the chat. It's really just the difference in the large load connection and EV forecasts denoted in that table on the top right.
Okay, thanks, Taylor. Sorry, I'm operating with limited resources here in my new configuration, so apologies. Okay, on that note, Byron, if you could hold your question, I'm going to let Lauren finish the presentation, and then we'll see where we're at time-wise.
Great. We don't have too much more. I do want to show what the slides look like. Next slide, please. I think after this. Yeah, slide 59 here shows the electric system winter peaks by scenario. So it's essentially the same information that you just saw a line chart of on the left-hand side, but it shows the component parts of what each scenario's assumptions, how much contribution to peak each one of those different assumptions has compared to the reference. So the component parts that we're showing here is kind of a like regular, residential and non-residential load, kind of core load. The darker teal in the middle there is the building electrification amounts. And large loads, so the data centers, and having an increased assumption there, you'll see mostly in S3 and S4. There's a little bit in the reference case in S1 and S2, but the higher assumption you can really see is that middle purple line. And then electric vehicles are on the top in that red shade. And so this really shows you the relative nature of those component parts, and that building electrification is really driving the differences in those peaks. And then next slide, please. The same is true, but just for the reverse this is the gas side and showing declining load. We've got residential on the bottom, and then non-residential would essentially be commercial and industrial. And we do show the reference in S1, everything essentially declining in the rates that you saw on the line chart. But this just shows, how much of that is residential and then versus the non-residential. I'll note that on S2 and S4, you'll see a little bit of that non-residential load continue out to 2050. And that's because we modeled this with the assumptions that there would be some remaining industrial customers that just have processes that aren't electrifiable, essentially. And then I believe we have a last slide after this. This is just showing on the gas side how many customers there are on the system over the course of the forecast period. you'll see that S2 and S4 being our most aggressive, as you saw in the load and the peaks, the customers pretty much go to that very minimal level around the 2041, 2042 timeframe with those very aggressive building electrification assumptions. And those are the key takeaways from my slides. I was trying to go a little bit fast to make sure we have time for everything else. And I
Thank you
will
so much, Lauren.
give it to you to Hillary if we have anything else.
Lauren, thank you so much for handling having a truncated amount of time to present, as well as having the facilitator disappear. So I appreciate your patience with me, and thank you everybody for your wonderful questions. There are some, it sounds like there's a couple outstanding in the chat that PSE staff are going to address in the chat. And so thank you for just kind of hanging tight with that. If there are any questions that we were not able to get to in this meeting today, they will be addressed in the follow-up report that will come out. So I know this was a lot of information that came your way today. I want to thank Jen and Nisi and Dan and Lauren for your presentations and for everybody who came online to answer questions. I do want to be cognizant of the fact that we have a public comment period, and I want to make sure that members of the public have an opportunity to ask their questions. So I'm just going to run through a few next steps, and then we're going to pivot to public comments. So if you could advance the slide, please, Jack. One more. One more. Okay, so we have a very kind of clear-cut feedback process. We are, of course, this little middle bubble in the slide right now where we're having this RPAG meeting. We engage people in feedback. 1 week after today's meeting, the feedback window will close for this, and my colleague Ben is going to post in the chat a link to the feedback form. So Ben, if you could go ahead and post that link. You are welcome to ask questions for the next week, and then in a month, PSE will post responses to all of the questions and feedback that came during the meeting and in the week after the meeting. So thank you for all the great questions and comments that are coming our way. And thanks, Ben, for posting that. So next slide, please. Our next activities, I mentioned in a week, the feedback time frame closes. That's on August 4th. And then our next RPAG meeting is on August 25th. So please mark your calendars. Next slide, please. There are all kinds of ways that you can provide input to PSE. There's an email address that you can send a message to. You can fill out the feedback form. It's both in the chat as well as online here, as you can see on screen. You can leave a voicemail at the phone number there. If you're not on our email list, please subscribe to the email list. And then this website here has all kinds of information. It has the presentation from RPAG meetings. It has summary notes, everything like that. So I encourage you to visit that website if you get an opportunity. Okay, next slide, please. Now we have come to our public comment opportunity. And for members of the public, we invite you to ask questions of PSE. And what I'd like to do first is ask for a show of hands of any members of the public who would like to provide feedback today. And I'm going to go ahead and take some notes so we know how many we're dealing with. I see Don Marsh's hand raised. Are there other members of the public who would like to provide feedback today? Peter Newcomb. Kyle Lucas. And am I missing anyone? Jack or Ben, am I missing anyone? Does that look right? Yeah, sounds like we have 3 members of the public who'd like to provide feedback. I'm going to give you a quick overview of how feedback happens. There will be a 3-minute timer on screen. We ask that you limit your comments to 3 minutes. We also ask that comments are shared respectfully. No personal attacks. All comments that come during public feedback time will also get incorporated in the feedback form that I just mentioned. And I think that is it. So without further ado, I'm going to take public comments in the order that they came in. And Jack is going to go ahead and do the countdown on screen. Don, I'm going to call you on camera and on mic. And as soon as Don starts talking, Jack, you can go ahead and start the clock.
All right, good afternoon. I'm Don Marsh, speaking on behalf of the Washington Clean Energy Coalition, an all-volunteer nonprofit comprised of many individuals and organizations who participated in previous advisory groups for more than 10 years before PSE refused to allow us to participate in these meetings. We partner with organizations such as Sierra Club, Third Act, 350.org chapters in multiple cities, Climate Action Bainbridge, Vashon Climate Action Team, and others. We are collectively dismayed and opposed to the ISP process PSE is conducting. The problem began in May when PSE compared two reference base cases. Reference A, with a ridiculous amount of 4-hour batteries being stretched way beyond their capacities, and reference B, which includes more gas peaker plant capacity than all other new resources combined: wind, solar, nuclear, and geothermal. When reference A failed to meet demand, PSE put all its eggs in the gas basket. PSE says, don't worry, we will study all kinds of sensitivities to develop our final preferred portfolio. The problem is that you can't get to a holistic, clean portfolio by starting with a gas-heavy plan and studying one incremental change at a time. In isolation, each sensitivity might fail, just like the battery solution in reference A. Although we may end up with a better portfolio than reference B, the final portfolio is likely to exceed emission targets in the Climate Commitment Act to the detriment of the environment and customers' wallets. We didn't want to lodge a theoretical complaint, so we developed a detailed alternative portfolio that uses a diverse collection of 100-hour batteries, vehicle-to-grid, virtual power plants, and geothermal energy to produce a portfolio that doesn't need peaker plants or a risky nuclear plant. According to our calculations, this would meet Washington's clean energy goals, both CETA and CCA, without costing customers any more than the reference B plan. In fact, our offering is exactly reference B, but substituting clean resources for PSE's gas plants and nuclear plant. We submitted this feedback to PSE before the June RPAG meeting and expressly asked that it be shared with RPAG members. PSE thanked us for our submission and said it would be valuable to the process. But the company did not share it with RPAG members or include any mention in the feedback report. This has severely harmed our trust in the process. RPAG members can read our report at our website, wacleanenergy.org. That's wacleanenergy.org. We insist that PSE study a real clean energy reference case rather than a straw man designed to fail. We are committed to making this a national issue if that is necessary to protect PSE's customers and the well-being of future generations. Thank you.
Thank you for those comments, Don. Our next speaker is Peter Newcomb. So Peter, you can go ahead and come on screen and on mic. Peter, are you there? I'm just going to give Peter a minute here. Ben, I just want to make sure that Peter is able to come on screen and on mic.
Yeah, he's a panelist now.
Yeah, okay. Okay, Peter, I think we'll turn back to you if you're able to come on screen and on mic, but I think at this point I'm going to pivot to Kyle Lucas. Kyle, do you want to come on screen? Okay, I'm not seeing Kyle.
Kyle's on now.
Okay. Kyle, are you there?
Hello?
Hi. Okay, Kyle, you are on. So you have 3 minutes. Jack, if you could go ahead and start the clock. Kyle, the mic is yours.
Oh, thank you, Hillary. This is Kyle Lucas. I'm chair of Urban Indians Northwest and here in Tumwater, Washington, and also Tenants United. We're a tenants advocacy group. And my concerns have to do with data centers. And, I had attended the integrated system planning meeting, you may recall, and I had concerns that I expressed there. And I'm learning, and this is my first meeting, attending this meeting today of this group. But I was concerned because I saw that you indicated data centers and you had some figures that you were using. But when I spoke yesterday, I was told, I think it was by Brian Tyson, that you currently have no data centers in your planning and that you're just punting over to the UTC, who have opened the docket, which I have yet to explore that information. But I was just kind of concerned that in your diagrams that you showed, your charts today, you were indicating you're counting data centers and projecting for data centers, but yesterday I was told that you don't have any and you don't have any figures or any kind of information. So I was just kind of concerned about that this is a big, huge question mark. We in community who care about water, our water resources are very finite water resources in a hydro state, predominantly hydro state, are very concerned about what the impacts are going to be from these data centers to our water supplies and, of course, to our energy costs, as well as to the natural environment and to fish and wildlife. So I just wanted to make those comments. I'm going to send some actual written comments because I want to go back through the slides and try to reference the point where I saw you had indicated addressing data centers in the work that you're doing here. Okay, well, thank you. This is kind of last second. I hadn't really planned to comment, but then I had noted that. Thank you very much.
Thank you, Kyle. We appreciate your comments. And I'm just going to check one more time to see if Peter Newcomb is online and would like to provide public comments. Okay, I am not hearing Peter. So with that, I think we are going to go ahead and wrap up this meeting. I just wanted to say thank you to everybody for joining us today. This is a really important process that is underway. There's a lot of information. We appreciate your patience as we provided all that information. Great questions, everybody on the RPAG. We are going to circle back. Ben posted in the chat, again, the feedback form. There's also a survey of the meeting that we'd love to invite our PAG members to please complete and let us know how we did. Our next meeting again is in August. We look forward to seeing you all there. And with that, I am going to hand it over to Jen Colson from PSE, who's going to provide our closing comments.
Great, thanks, Hillary. And thanks everyone for your time today. That was a lot of material, a lot of great discussion. We had a lot of good questions and feedback. So really looking forward to the next conversation that we have with you. Thank you again. Have a good rest of your day.